slash play slash note or slash play slash chord. It doesn't matter what you put in there, as long as it's textual, and you can have as many of those strung together as you like, and sometimes, depending on what you're using to drive your OSC controls, you may need to do that. The important thing is that what's at the receiving end matches what's being sent at the address end. So if you're sending an OSC message to play note, you've got to be looking for play note at the other end, otherwise you won't get it. And there's one slight catch with Sonic Pi we'll get onto in a minute. You then have data, and as I said, you're not stuck to just numbers as you are with MIDI. Here we could send a symbolic note, colon C4 from Sonic Pi, or a string of notes to play a chord. We also need to tell where we're going to send this, the destination IP where it's going to go to, and the port of which is listening to that. So in Sonic Pi, because it can send and receive OSC messages, this is a program which will let you test that. First of all, Sonic Pi has the simple command use_OSC that tells it where you're going to send OSC messages by default. In this case, I've got SpeechMark's local host. That's the loopback address of a machine, which doesn't necessarily have to have the internet connected to it, 127.0.0.1, and you can put that in if you like. And Sonic Pi has the rather odd port number, you soon learn it, 4559 is the port at which it's listening for incoming OSC messages. And to send it, it's as simple as saying OSC /play/note in SpeechMarks, that's my address, and then I've got 4 items being sent. A note, a name of a synth, 0.5 and 0.2, which are going to set the duration and the volume of that note. In order to receive it, you don't know when it's going to come, so you use the construct in Sonic Pi, which is a live loop. This is basically a loop that goes round and round and round, and this one is going to wait for a sync. That's basically the queue and sync system which Sonic Pi uses, is that you can set something up and ask it to sync to something being received, and it will sit there twiddling its thumbs until it receives that cue which is sent. And there are words queue and sync in Sonic Pi that do this. MIDI works the same way. You can send MIDI devices into Sonic Pi, like a keyboard which I've got languishing around somewhere. I'm not actually going to have time to use that today. This sends out MIDI commands, and Sonic Pi can receive these and then respond and get it to play a note when it does so. But we're looking at OSC today. And here is a second example, OSC play chord. This has got 3 notes to play together, different synth, and a live loop going around here. And we're extracting the information by saying, when you receive this, and here the eagle-eyed among you would have seen that we're not actually looking for what we sent. We sent an address /note /play/note. We actually have to synchronize on /OSC /play/note. And this is because Sonic Pi is receiving information from lots of potential sources. Internally, possibly a MIDI keyboard connected, and OSC messages coming in. And it prepends to MIDI messages coming in /MIDI, and it prepends to OSC messages coming in /OSC. And as long as you learn that on the receive side you need to put /OSC at the beginning, then everything's hunky-dory. So there's the text of this language. I'm going to copy that. I'm going to switch to Sonic Pi, and I'm going to paste it in there. And we're going to simply play this. Let's make it a bit louder so you can hear it. And as you can hear, it plays a single note, and then it plays a chord. And if we look over here in the sort of logging section, let's make that a bit wider so that you can see more of it. Sorry, it's a low resolution projector, so I can't really see everything at once. But you can see that we're sending an OSC message to localhost, that's this machine, port 4559, play chord is the address, and those are the items of data which we're sending there. And a bit further up, there's the first one being sent. If I was to change this and take out the OSC at the beginning there, and we run this again, we only hear the chord, because we're not looking for what's actually coming in. The cue that it's looking for, the Q that it's looking for down here at the bottom, we can see in yellow, and this section here, let's move that a bit to the left again, is looking for OSC play note, the top entry there. We're looking for play note coming in, and that's not right. We need to put the OSC in the beginning there, and if we do that, then this will work again. Right, I can go home now because I've told you how OSC works with Sonic Pi. You can send an OSC message from Sonic Pi and you can receive it back in. But that's just the tip of the iceberg, and where it gets really interesting is when we expand onto slightly further afield things. I'm going through this very fast, but all of this, you'll get a piece of paper at the end with lots of references on it. You can go and look at them at your leisure and see how to use things. Now, the next thing is just showing there are two ways of extracting the data which we get. This is the same program done twice, looking at OSC play note, and we can either put a variable for each of the items we expect to receive there, the note, the synth, the duration and the volume, or we can put one so that's the first, it's this one again. Or we can put one variable there, in which case this effectively becomes a list. And if we say B is equal to sync there, then we have to refer to the various items in that list to get that going. But these two programs are exactly the same. The second part is, as we've just done, the first part is the alternative way. And just to show that they both do exactly the same thing, they both play the same note. And you can see I asked it to print by using the puts B command. Puts in Sonic Pi and Ruby, it means print or put on the screen. And you can see that it put the items here that we sent, which are there, the 4 items as a list. So B0 would give you the C4, B1 would give you that, B2, B3. Right, well that's all pretty boring so far. Let's come back here and make it do something more interesting. When I talk about Sonic Pi, I invariably use Frere Jacques because it can demonstrate so many things with it. Here we're going to use 2 versions of Sonic Pi, one running on the Pi Seed, one running on the Mac, and we're going to synchronize them together using OSC and get them both playing a round of Frere Jacques. Here is the program, which is quite long. You could just about probably read it there. I just want to point out that I'm using a command called set and get, which is in the later versions of Sonic Pi. Think of it as a way of storing a global variable. So if we say set tempo, t, it stores at that point in the timeline something which is referenced by the word tempo and which has the value which is given in t. And later on in the program, down towards the bottom, you can see tempo equals get, inside close brackets, :t, that gets back the value. And it's a way of taking something and passing it into a live loop, or from one live loop to another. You could just set variables outside, but Sam prefers you not to do that because there are, you can get ambiguities as to what the actual value is going to be if you get 2 things happening at the same time. So this is a better way to do that. I've got all the notes of Sonic Pi, C, D, E, C, C, D, E, C, C, E, F, and so on. I've got all the durations of that notes in the second of those lists. I've got different volumes, piano, piano, medium 40, 3 pianos, a medium 40, piano, piano, medium 40, 40. And so we're going to da, 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 da as we play. And the live loop at the bottom is going to do the playing. And what we do is we get these values, notes, durations, volumes and tempo. We set the tempo by saying use this number of beats per minute for this tempo. And then one of my favourite constructs in Ruby, this is not a documented command in Sonic Pi, but it's a way whereby you can link or zip together 3 lists, notes.zip, durations and volumes. And that takes these 3 lists together and we traverse round them and we take corresponding values as we go round. So the first time we get C4, 1 and P, then D4, 1 and P, then E4, 1 and M, and so on all the way through. And then we're going to send that with an OSC command addressed to hello play. Those are the variables N, D, V, S and tempo, which we're going to send. We sleep for the duration of the note and we go round again. And we're going to repeat it, and in the fourth line it says S equals get synth tick. It's going to choose the next tick, the next synth in the list, and so it will play repeatedly. I'm going to copy this now and place it into Sonic Pi. Here we go, and we'll start it playing. And if you look at the graph here, you can see the volume changes very clearly there, but you can't hear them. See that note louder, louder, louder. And what we're doing is we're sending the OSC messages, and in the first live loop, we are, the first live loop up here, we are syncing to OSC hello play. We're taking the variables out that we've sent, and we're using them to play a note there. Play the note with that amplitude, sustained for 9/10 of the duration, and released for 1/10 of the duration. And you can hear the synths changing. Now that's all one machine, but where it gets interesting is if I take my Pi top seed here, and this has got set into it, and if I just come over here, I can put a video on which shows you the Pi top seed there. Let's just move that up a bit so you can see it. There we are. Here's the Pi top seed. You can see it's got a live loop which is going to sync on incoming OSC hello play 3, because we're actually going to add a separate one which is addressed to this machine rather than to the local host. But it's essentially the same as the program which is over there. I'll just put that down, and we will come on here. And to save time, I'm just going to take this second one here and copy it and put it on the end of the program down here. And this is another live loop, which is...
First line.
Sorry?
You just missed the first line.
I missed it, did I? Okay, let's just go back again and do that. Thank you, because that would have given us a slight problem. Copy that, and we'll go back to here, and we'll paste that on the end. That live loop, send OS3, it's exactly the same as send OSC, except when we get down to the OSC call. Here we're using OSC, and OSC uses the default setting that we set at the beginning to use localhost and port 4559. There is an alternative way of sending OSC commands in Sonic Pi, which is to use OSC_send. And what this does, you need to specify the address and the port as the first part of the command before you get to the address and the information to send. And 172.20.10.2 is the address of my Pi top seed. And so that is going to send that there. Just to differentiate between them, I've changed the message to hello, the address to hello play 3. It could be hello play because they're both going to different addresses. It wouldn't matter, but it's probably easier to keep them separate. So now we'll just take the volume of this one down a little bit to balance them up again, because this has only got a small little boom bar there. And let's start this playing, and I'm going to bring up the other one in front so you'll be able to see that as well. We'll move this a bit to the side and move that up here, and then if I get that on there, we will start this playing. Oops, I did it twice. Started playing. No, one further thing I want to do actually, so we're not waiting all day. I was originally going to use 3 of these. I'm only using 2, so I'm going to delay this loop 8 beats. Da da 1, 2, 3, 4, 5, 6, 7, 8, and then the second live loop will start, and so we get the 2 parts coming in like a round.
Cannon.
A cannon, yes. Yeah. Okay. So let's come up here and start that going. 5, 6, 7, 8, this start. And why stop at 2? Why not have a room full of these? I did that back in the early 80s with BBC Micros. I had 18 BBC Micros all synchronised together playing music with different parts of the Bach Brandenburg. And the timing's not too bad. You may have noticed I used a command in Sonic Pi called Time Warp on the play one for this. I'd actually delayed this one because it's a bit of a faster machine for this poor thing to keep up, just to get them synchronised, and that was done by experiment. Okay, we must go on because there is so much more to do. And the next thing I'm going to do is to show you this. Touch OSC is an app which runs on an iPhone, an iPad or an Android device, and it's one of the best £5 I ever spent, because it gives you a virtual device which you can use to send OSC messages or indeed MIDI messages, and you can build up very complex things with it in order to control Sonic Pi. And although I'm using it on a Mac to do this, because we're using OSC and not MIDI, it's very easy to send this straight to a Raspberry Pi as well. It's just easier to get the screens if I'm doing it on here. So, how does this work? Well, we have a free editor that comes with the machine. There's a Mac version and a Windows version for actually creating the screens. And the screen starts off black, and you simply put objects on it by right-clicking and choosing an object. Here's an object called a multi-toggle, which is an array of switches, and if I take that down to just one row and 4 and resize it, we've got 4 switches. We can select between these and make them exclusive so that one of those 4 can be on at a time, and we'll see that a bit later, but I'm going to remove that and talk at the 3 simple ones here. We've got a LED there, which is going to appear yellow. It has an OSC address of /touch/LED1. It's called LED1, and the black part of the screen I've called touch. So that object is addressed by /touch/LED1. You send it 0, it's off, send it 1, it's on. This is a slider which we can move up and down. I've called it pitch because that's what we're going to alter in Sonic Pi, and has an address /touch/pitch arranged from 0 to 1. This is a push button which is green. I've called it push 1. It is addressed by /touch/push1, and if we send it, it sends 0 when it's released, it sends 1 when it's pushed, and both of those are enabled down here. We send that by simply saying sync, and it can be picked up on our machine here. If I put that on there and bring back the video so you can see it, there it is. It's already there, and if we were to go out of that screen, it's called sample, we could come up here and say add. It's found my MacBook Pro twice because it's connected by cable and by wireless, and we simply say yes, I want that. Warning, I'm going to overwrite it. Is that okay? Yes, so that's done. The other thing I want to show you here is we can set up the addresses where this is going to be sent. 172.20.10.4 is the address of my Mac. 4559, remember, that's where Sonic Pi gets OSC coming in. This is going to listen on port 9000, and it has an address of 172.20.10.5, and that's what we will set Sonic Pi up to use from there. We go back to the screen and you can see it's there, and we're finished with this, so we'll get rid of the editor, hide that, and instead we're going to go on and have a look at the program which uses this, and that's all we need to talk to this with Sonic Pi. Again, the use OSC command to set the default addresses it's going to send to. In this case, not localhost, it's going to send to here on port 9000. I'm using the set command that I referred to briefly for global variables here. I'm setting pitch to 60. That's the note which is a C, and I'm sending an OSC message to touch pitch, that's the slider, and I'm setting it quarter of the way up. And why quarter of the way up? Well, later on, when we get it back, we're going to multiply its value by 48 and add it to 48. Quarter of 48 is 12, 12 plus 48 is 60. So those are the corresponding note and default position. And we simply then have another live loop which is going to sync on the button being pushed. When it checks that the button's being pushed, it checks whether the first thing it receives, there's only actually one here, is 1. If it is, it's going to play what the current pitch is and release it in 0.2 seconds. It's going to send an OSC message to turn the LED on, wait for 0.2 of a second and turn the LED off. So let's put that into Sonic Pi, and here we go. And we do that, and we'll bring the screen up with this on here, move it to one side, and I want you to watch what happens to the slider when I start the program. What do you think will happen? Yeah? That's right, exactly right. 1, 2, 3, go. There it goes. Okay, so this is a virtual mechanical device, except it's on a screen and we simply use our fingers to move these. If we press the green button, it plays a note. Let's make it louder because I'm only using the default synth, which isn't very loud. There we are. And you can see that it flashes the yellow LED. Turn that up, different pitch. And we're not stuck to semitones, we can go to anything we like. Okay, so lots of things you can do with this. And the next one is to come back here and use something which is a bit more useful, like a keyboard. And this is a keyboard I designed. It simply switches. There's a multiple toggle here, which is why I showed you before. We can select one of 4 items there, 2 sliders, and these are just elongated push buttons. You just stretch them and colour some of them dark coloured black and some of them green. And this one is set so that when we press the second button, let's make that one a bit bigger, when you press the third button there, which is a D, you'll see its name is D1 up at the top there, and I've arranged it, therefore it will be addressed as /keyBD/D and D1, and I've arranged that it gives a value of 3 when it's pressed, and the next key will give 4 up to 25, so we can simply add those numbers as an offset to change the pitch of the note we're going to play. So that's there. Let's now come out of that and go back to Sonic Pi and load in here the program which will do this. Again, this is all written up so you can look at it at your leisure rather than the express speed at which I'm going through these. Touch OSC keyboard, that's the one we want. Open. There we are. And we're going to also, if we put this on again, switch the layout here to one which is called Phone Keyboard OSC, because this is actually size, so it will work on an iPhone as well. It's a bit bigger than it would be on that. And here we are, and again, we're going to use the same old business of sending some OSC messages to set up the initial values. When we run the program, 3, 2, 1, go. And you can see that the sliders and switches have been set up appropriately. And so we can start playing this. Now I'm afraid there is a bit of lag on this, and that's because I'm using an iPhone as my network. It's tethering everything, and so it's a bit slow. When I do this on my normal router at home, there's no lag at all, and it works very well indeed. We can change the synth. Here's an FM synth. We can change the release time, longer notes. We can change the octave. We can change the volume. I'll turn it down because we're going to this one, which is TP303, which is a lot louder. So lots of fun to be had, and that is all published. You can load it in, and it will work on a Raspberry Pi as well. Okay, next we have got to where? I think now we're going to move on to something which will be close to your heart. We'll actually use a Raspberry Pi again. I don't have to use one here, but we're going to use this one, which is running on a Pi Zero W. Don't worry about the dongle yet, that's for later. And this has got a Raspberry Pro Hut on it, which is just a breadboard with the pins brought out in a nice numerical order, so it's very easy for controlling things and allowing you to quickly make up little circuits. I've got 3 big LEDs here, red, white and blue, attached to 3 of the pins and a push button. And the first thing I want to do is to make sure that it survived the journey here and is still working. And so we've got a little Python program, and yes, I said we'd be doing some Python. And the reason that Python is good is because of the superb Gpio 0 library, which makes things very easy. When the first Raspberry Pi came out, it was horrible. You had to set things with an input or output and all sorts of other paraphernalia to get things going. Now you just say R is a LED on pin 20, white on LED 17, and a blue one on LED 14, and a button on pin 24. We're going to turn all three on, leave them on for two seconds, turn them off, and then we're going to check that when we press the button it turns the blue on, and when we release it it turns the blue off. So we'll take that little, no, we don't want to do that, that's in the terminal. I've SSH'd or connected into that because it's running headless, and here's the same program. I'm going to run a Python 3 test Pi, and here, if we take that out of the way, you might be able to see. Let's just run that. Let's see what happens. Yes, all three LEDs have gone on, they've all gone off, and if I pick that up and gingerly press the button, the blue one is going on while the button is pressed. Okay? So we know that all of those items are working, but now the interesting bit, rather than using buttons there and programs directly to do it, we're going to use Sonic Pi to drive it. Sonic Pi sends OSC messages. It can receive OSC messages. So all we need to do is to add in something which will send and receive OSC messages in Python. And there's a very nice little Python library called Python-OSC, and you just use pip3 to load it into your machine. And then I looked at some of the examples of this, scratched my head a bit because I'm not really a Python programmer, but managed to cobble it together so that it actually works. And if we move over here to, where have we got to? Oh, I don't know my Twitter's on. To here. We have got somewhere down here, there. That is the program which is going to do the whole thing. And if I start at the top, you may be more comfortable. If you've used any Python programming, you can see the Gpio library being loaded and various bits of the Python OSC library being loaded in there. We've set up our buttons, and this is going to be what happens when we press the button. It's going to call this function message, which is going to turn the white LED on. It's then going to send some OSC messages. Seen /play before, things like that? And this is going to send the number 48 the first time round this loop, and then it's going to add, looking up a value, an offset of 0, 2, 4, 5, 7, 9, 11, 12, and down to 0 again. It's going to play up a scale, then play down a scale, back to 0 again when the button is pushed. We've got, this is going to be how we deal with the LEDs. At the bottom, we've got starting up an OSC server, and the way this works is that we set up what are called dispatchers. These are simply looking, if you like, for sync commands coming in for a particular OSC message coming in. /LED control, when it sees that, we don't need to put the OSC at the beginning here because this is not Sonic Pi. It's going to have a little script called handle LEDs, and it's going to pass two pieces of data to them, R and B. So when we move up here, here is the function, and if R is 1, it's going to turn the red on, otherwise it's turning it off. If B is 1, it'll turn blue on and blue off. So we can have any combination from 0, 0 up to 1, 1 for the combination of LEDs we want. Right, let's now move back to here, and I'm going to quit that program, and instead I'm going to move to the previous one, which is that one, called SP-OSC Handler. That's what we were just looking at. It has two pieces of information in it. It needs to know the address of the machine it's running on, and we can't use localhost there because that locks it out from the network. You have to actually use the IP address that it's on the network, and it also needs to know the IP address where Sonic Pi is, which is SP 172.20.10.4. So we start that running. There it goes, and it's now sitting twiddling its thumbs waiting for OSC messages to come in, and these are going to come from Sonic Pi. We will load in the program Gpio Control. Go away, I don't want to save you. There it is, and it's not a particularly long program, it's a very simple program. It's setting up the address, and the main thing is a live loop at the bottom, which is going to play a scale which is going to increase. And S is the value of the note it's currently playing, If that's on the second octave as it goes up, it's going to send lead control 1 0 and turn the red lead on. If it's not in the second octave, in other words in the bottom octave, it's going to send lead control 0 1 and turn the blue one on. So let's start that going, and hopefully, there we are. You can see that it's oscillating between the blue lead on in the lower octave and the red lead on in the upper octave. And if we stop that from running, it stops just on whatever lead was last on. We'll start it again. And I'm going to press the button. What's the button going to do? Can you remember what I said it would do? We play a scale on Sonic Pi going up and down. And that's just sending lots of OSC messages, one for each note, to play and play it repeatedly. So you can see that Sonic Pi really becomes something to start looking at if you're a Gpio junkie and that's all you do. Then have a look at Sonic Pi, because you can actually control things very, very easily in both directions using that. So that takes us on to the next item, and I'm probably going to run out of time fairly soon, so I better whiz on. This is actually using the same machine, multi-purpose things, Raspberry Pis, and I'm simply going to stop that. Oh, by the way, I got to print some of the information coming in there, and that test message was just another message that this was sending, and it simply just will print out whatever you send to it. But you'll see that if you look at the write-up of this. I'm not going to talk about it now. But what I am going to talk about is using one of these, PS3 games controller. You get for about 15 quid. I've never played a game with this in my life, but what I do use it for is controlling robots and controlling Sonic Pi. That is the dongle for that, and when I press a button here, it's now linked, that's gone off. And we're going to run the program here to... Oh no, not test, we've done that. We're going to run this program, that one, ps3.py. It only needs to know the address of this machine, which is going to send stuff to it. Nothing's being sent to it, it's a one-way communication. So we start that off. It won't show us anything. I don't think, oh, it just says it's working. And if we now switch to here, and we load in the program for this end, which is called PS3 Play. And all this is lots of live loops, each one of which is looking for a particular OSC message. Because if I move this a bit to the side, so you can see messages coming in, if I press a button, you can see that each button is sending a different OSC message. When I press those, you can see in purple in the bottom right. And if I use one of the sliders, that one's the right up down slider, and so it's sending an OSC address to /RUD. That's the right left right slider. That's the left up down slider. That's the left left right slider. So we've got all that information coming in, and we can do whatever we like with OSC messages in Sonic Pi. And this is what we like. So let's just turn that on. We won't have it too loud, otherwise you'll be jumping out of your seats with some of these things. That's now started. So let's just try one of these. Let's try using these. Not very loud. Let's make the volume up a bit. Or we can do a continuous note, which I did by pressing the button on that. And we can change the synths that we're going to use. Let's just turn that one off temporarily. I can turn it off and bring it back on again, because it just goes on for about, I think I said it for about 6,000 seconds or something like that. But what we can do is we can change the synths by flipping one of these to the right or the left. We're now on TB303. Let's just stop that note, that long note, start another one, and turn the volume down to... Oh, I turned it off here. There we are. That's doing the cut-off value of the note, left, right, and it's doing the up and down. I can put the long note on because it's quite nice. simply running down a little bit for that. Then we can play along to it, and I'm going to press this button, which will turn the button to full volume. Lots of fun with that, and just another example. This will also be used in very similar software to control a robot buggy. I've got one of the monster boards around the garden using that. Okay, so let's stop that, and now I want to come back to something else which I'm sure a lot of you have access to, a Pytop Seed, and this one has got a sense hat on it. Well, Sense Hat has got LEDs on it, it's got a joystick on it, so why not control Sonic Pi with it? Or use Sonic Pi to control it? And that's what we're going to do next. We need the usual glue, which is a little Python program. We need a Python program at any rate to talk to the Sense Hat, and that's well documented. We add the same OSC server stuff to that, and I've got it on the program here. Let's just switch to this screen, make it a bit bigger because everything's going to be on there, and we'll turn that off, and we'll turn the camera on, which is what we're going to need. Right, I'm just going to switch this over to the other program, which is on buffer 1. That's the one. And up here I've got ready to run the Python program, which is called Sense Test Server. This one's face. This is one I wrote last night. I had it just flashing all the LEDs together. I thought that's boring. So I've got a happy face and I've got a sad face on here. And we'll start that running by pressing the keyboard there. That's it, serving. I'm just using the loopback address here because there's nothing else involved except this machine. And we're going to look at the program here. And that is simply going to go round a little loop here, and it's going to alternate because of that tick function, and if it's divisible by 2, the value, it will do the top thing, otherwise it'll do the bottom thing, and it's simply going to play a major chord in C or a minor chord in C, and it's going to send the OSC message LED control 01 or LED control 10. Well, let's see what it actually does when we do this. There you are, sad face, happy face, alternating, all controlled by Sonic Pi. We could change the speed if we want. We could make let's just do that. Let's change this to 1 second here. I'll put in 1 there, and we'll rerun the program. And it's now dropped to doing it second apart. But we've also got a joystick in here. So what we can also do with this is to move the joystick, let's put that up there, and we can take the joystick and we can just do this. If I can find it, can't see in the dark, there we are. So it's just moving one white LED around, and from the XY coordinates of where that is, it's working out a pitch, and it's using that to beat Sonic Pi. So you've got two-way control there. You've got stuff coming from the Sense app to drive Sonic Pi, very similar to using the button here, almost exactly the same. And you've got stuff going from Sonic Pi, very much the same, just LED control at 01 or 10, and we're simply using it to choose which image to display on that. So that gives us that. So let's just stop that from running. Which you can do with that. Stop, and just to tidy things up a bit, we can uncomment 2 lines here at the top, and we can run that again, and all that's going is to send OSC LED control 00, so it will turn both faces off. Run it, there you are, so everything's left nice and tidy. And that brings us to this. This is Neopixels, produced by Alex Eames. It's an Inspiring, and you can actually address any of these LEDs by Sonic Pi again. Again, the same sort of business, an OSC server and some Python code to run this, and then you play some sounds in Sonic Pi and you actually control that. So let's move that to that, and to do that we need to take the other machine, which is machine number 6 here. That's me out of time. Can I just show this? Nobody's objecting yet? Right, until somebody stops me I shall go on. We'll start that on, just turn that on, one light on and off just to show that that's actually working. And now if we go back to Sonic Pi, we can load in here another program, and this one is slightly a bit more complicated because there's some quite, not as difficult to control the layers, but working out which ones you want to go on when can be quite tricky. I think the best thing is just to play this, and it's quite a nice little demonstration. Here we go. Brightness is altering some of the two of these. That red one. So there we are. I haven't got massive more things, but I haven't got time to show you. For example, there's a nice little project that Mike Smith did called the Hexone Project. I've rewritten that for Sonic Pi, so you can actually produce nice little rhythms and things with that. I've got a visualizer, which is somewhere. I've got a visualizer there, which you can make Sonic Pi semi-transparent, and you can have shapes and things with it. And just starting up should be a Christmas tree, the Pi Hat Christmas tree, which has got Sonic Pi. There's a headless Sonic Pi booting from scratch there. Takes a minute or so to get going, but as we finish, that will be what we can see. And there is a list of lots of addresses. It's slightly different, I think, to this one. I've added a couple, but if you want to take one of those and go away and read any of the stuff I've done, you're welcome to it. I don't think there's probably time for any questions, but I will be around for the rest of the day because I've already overrun. Okay, thank you very much.